For this section, 3.3, we're going to break it up into 2 days. I sent you all of the notes at once, but we're going to do zeros, factor, and the remainder theorem, and then separately we're going to look at roots and sums of polynomials. Sums and products of polynomials separately because I think it's a little bit tricky, and it's one of those things that we haven't actually done before. So when we look at this previous knowledge here regarding zeros, factors, and remainders, if I look at something like 34 into 485, we have a divisor and a dividend. And so when I divide this out, I get 134 subtract. Why are we doing this longhand? Because we're going to do it with polynomials also, and then bring down our 5. And then 34 goes into 145 4 times, and that gives us 136. You can use your calculator if you need to, or you can do longhand. And then when we subtract, we get 9. So we have a remainder of 9. So you can write this 2 ways. You can write that 34 times 14 plus 9 equals 485. Or we can look at it in terms of a fraction. So you can say that 485 divided by 34 is equal to 14 and 9/34. So those are the same thing, and this is what we're doing when we're doing polynomial long division. So remember to reference or couch it in this idea of what long division is, what remainders are, and how we can write division as a fraction, and fraction can always be rewritten as a mixed number. So let's make sure we are looking at that. So any number can be written as a fraction so long as it's rational. Any rational number can be written as a fraction. So our main goals to be looking for this section is to use polynomial division and synthetic division and understand what each gives us. So what do we get when we divide a polynomial out, and why do we do synthetic division? It's very much like that substitution thing we did the other day. So it's kind of a trick that allows us to quickly run through fast division. And then given a root of a polynomial, either real or complex, we're going to look at that one. Factor the polynomial completely. So first thing first, let's divide polynomials. Let's do this beast right here. If you remember, I have this polynomial up here and I'm dividing it by x minus 2, so dividend, divisor, and this is a nice linear term, so there's nothing missing, so I don't need to write 0x squared or anything like that because every term has a coefficient. So 2x squared times x gives us 2x cubed, and then we subtract. Remember, it goes to each term. Negative 4x squared also, and then we're going to subtract the whole quantity. So you can either subtract the quantity or change each to its opposite and then add. It doesn't matter which way you choose. So these should go to 0 because we designed it that way. Become a 0. And then negative 5 minus negative 4 is negative 1x squared. And then just like on the other problem, we drop our next term. So plus 6x. Now, this and this is where we're going to go next. We're going to ask the question, how many times does x go into x squared? Negative. Well, it goes in negative 1x times. And then we're going to do the same thing. We're going to distribute to each term and then subtract. So this is going to be negative 1x squared and then positive 2x. And then we're going to subtract the quantity. So 0. And then minus positive is going to give us 4x. And then again, drop our last term. X goes into 4x, positive 4 times. Distribute, minus 8. And then we subtract. That becomes 0. Yay! Uh-oh, we have a remainder. That's okay. It just tells us something. It tells us that if there is a remainder, then the divisor is not a factor, okay? Which implies that if the remainder equals 0, it is a factor, and that is the remainder theorem. Okay. How can I rewrite this like we did with the 34 and the 14 and the, what was it, a 9 or something like that? We're going to write it just like we did. We can say that 2x cubed minus 5x squared plus 6x minus 3 divided by x minus 2 can be rewritten as 2x squared minus 1x plus 4 plus, just like we did earlier with the 9/34 as our remainder, we're going to plus our remainder here as 5 over x minus 2. Same divisor here, same divisor here. Let's look back really quick. So just like on this guy, we had our dividend over divisor, and then we have our whole number from up here, and then we write our remainder over the initial divisor. So that's what we have right here. And apparently I just wrote it right there, so if you need a second to fill that out, you can. So the question was, is x minus 2 a factor of p of x? No, and you can say as your reasoning, because remainder does not equal 0. I'm going to pause and we're going to go over synthetic division in the next video.